lot of times you're just doing your wavelength to frequency problem, and then all of a sudden they throw in a, hey, what about per mole of photons? Anytime they say per mole of whatever, you just multiply by 6.2 times 10 to the 23rd. Okay? Cool? All right. The last one was just electron configuration, right? Did anybody need me to go over that? No? That was good. Okay. So, guys, 25. Do you guys know what type of radiation that is? Okay, I want you to look on here. Numa, I don't know if we need to videotape this, or if we can't. Are you already?
Yeah.
That's fine. Okay, so what I want you to see is, I just want you to have a frame of reference. You do not have to memorize that electromagnetic chart in your book, okay? You don't have to know that, but I just want to give you a frame of reference. Colored light, our visible spectrum, is a very, very, very small part of the electromagnetic spectrum. And it runs from, this says 390, I usually say about 400 to 700, okay? That's an easier number, an easier range to remember. So 400 to 700 is violet light to red light, okay? And that is wavelength. Those are nanometers, 400 to 700. And so here's the interesting thing. I want you to think about that. 400, okay, to 700, and these are nanometers, okay? Which of these has the highest frequency?
400.
400, right? Because we said before that frequency and wavelength were inversely proportional, right? Speed of light is wavelength times frequency. So if wavelength is high, then frequency is low, and vice versa. So since this is the lower wavelength, it is the higher frequency, right? And this is the lower frequency. So let me ask you this question, looking at this formula right here. When frequency, how are energy and frequency related?
Directly.
If this goes up, this goes up. So, which is higher in energy?
700.
400.
Because it's higher frequency, it's higher energy. And this is lower energy. So, let me ask you this question. How is energy and wavelength proportional? Directly proportional or inversely proportional? Higher energy, lower wavelength. You see that? And I usually think of these are short little frazzled waves. It's just kind of a way I think about it. And these are long and lazy. That's not a very good wavelength, but you get the idea. So long and lazy, lower energy. Short and frazzled, higher energy. Okay? That this also kind of reminds me, and I'm glad you're taping, is there's another way to do this problem, and some of you saw it on the video. And that way is to combine these formulas and then work the problem. How many of you guys did it that way? No? Oh. Yeah.
Oh, so
Okay.
set them equal to each other?
Yes. So I'm just gonna show you, I'm gonna model that method. Okay? We're gonna get the same answer. So okay, so let's just look at that real quick. If I rearrange this formula, then we know that speed of light over wavelength is frequency. So if I take this and substitute it in here, then we have a new formula, which is energy equals H times C over wavelength. Y'all see how that fit together?
Yeah.
Notice on the green sheet that you are not given the combined formula. So that's why I like to teach it this formula than this formula. And also, if it's a free response problem, you guys are starting to kind of know the format. Sometimes A is, hey, what's the frequency? And B is, what's the energy? So sometimes that's a good pattern. But if it's asking you to go to all the way from wavelength to energy, you are certainly welcome to do this. Some of you like this better. And so when you're plugging it in, you're simply going to take 6.626 times 10 to the negative 34 joules times a second times the speed of light, 3 times 10 to the 8th meters per second, or you can use the 2.9981 over, again, this is meters, so you've got to use the meter, not the nanometer version, 25 times 10 to the negative 9th meters. And in one fell swoop, you will get this energy, 7.95 times 10 to the negative 18 joules. It's kind of efficient, okay? But it doesn't matter. If you like combining formulas, go for it. If you don't, these formulas are on the green sheet. You never have to memorize them. And you don't have to do the algebra to combine them, okay? It's whatever you really feel comfortable with. Remember, this always is per 1 photon. And usually that's what you're asked for. So if they ever ask for a mole of it, then you're just going to multiply by your Avogadro's number. Okay? Cool.